if t is a real number such that t plus 1 over t equals to 3, what is the value of t to the 5th power plus 1 over t to the 5th power? I'm going to solve this problem in two ways. But before I'm going to solve it, I want to kind of mention one fact that's very useful to know, and that fact is called Binomial Theorem. So every time when you have something like a plus b to the power n, where n is a positive integer, to quickly expand this, it's advisable to know what binomial theorem is. So there are actually two things together, binomial theorem and Pascal's triangle. Well, normally, when you study binomial theorem, Pascal's triangle comes in the package. So you learn that. But you really need both of those things to quickly deal with something like this. And that's expression for n equals to 5 will be very useful today. Now, even if you don't know binomial theorem, there are a couple of things I recommend people to know, just learn by heart. One is the case when a plus b to the power of n, when n equals to 2, so a plus b squared, this formula. Another one is when n equals to 3. Those two formulas are very useful, and I recommend just knowing them. Okay. Now today, as I mentioned, we need a plus b to the 5th power. Now if you don't know binomial theorem, you can actually, but know these two formulas, you can see that really a plus b to the 5th power is a plus b to the 3rd power times a plus b to the 2nd power. So those two guys. So you can expand on those parentheses and then multiply this by this, okay? Now, if you know binomial theorem, you'll find that you can quickly write out this expression for a plus b to the 5th power. It's actually going to be 6 terms, okay? That's a useful fact to know for today, so we're going to put it on the top. And now let's deal with this guy. What we can do is say, well, this is an equation for t. We can solve it, right? Find t, and then take that t and put it in this expression, and find the value, and that's it. That is a straightforward way. So to solve this equation, I need to multiply both parts of it by t. I get this. Then I'm going to move 3 to the left. I get t squared minus 3t plus 1 equals to 0. This is a quadratic equation, which I presume you know how to solve. The general formula is written here. So if I have an equation, at squared plus bt plus c, where a, b, and c are constants, these are the solutions. These are the roots of this equation. There are in general two roots, one with plus sign, one with minus sign. So in our case, a will be 1, b will be minus 3, and c will be 1. If you plug those numbers here, we got two roots. One is 3 plus square root of 5 over 2. The other 3 minus square root of 5 over 2. So now what we really need to do, we need to try them both, plug them in this formula, and see what we're going to get. So let's start with plus sign. This is what we're going to see, right? This is our t, this is 1 over t, both of them in power of 5. Now we can separate numerator from denominator, like this. And now the question is what to do next. We have this ugly square root of 5 plus 3 in numerator here. That's probably a better thing. And we have very, very bad thing in denominator. Okay? What to do about this? Well, obviously we can bring to a common denominator by basically expanding this, getting 6 terms here, 6 terms here, then multiplying 6 by 6, getting a mess, really. Or we can do something else, okay? So I vote to do something else. And something else is actually standard procedure how to get rid of irrationality in denominator. To do this, we really need to remember this formula, a plus b times a minus b. Now, in our case, a will be 3, b will be square root of 5. In this case, these two parentheses give me 4. I get rid of irrationality. But the problem is, well, where do I get this 3 minus square root of 5? I don't have it. Well, first of all, let's start with 1 over 3 plus square root of 5, where we have irrationality in denominator. And now what we're going to do, the trick is to multiply and divide by this 3 minus square root of 5. Now in denominator, I have my 4, I have this. So the final answer is like this. So this is a standard way of taking this irrationality out of denominator and bringing it to the numerator. And presumably, we can handle numerators better than denominators. Now, in my case here, I don't just have 1 over 3 plus square root of 5. I have 1 over 3 plus square root of 5 to the power of 5. So what it means that we need to take this to the power of 5. And this is what I'm going to get here. Now, we can simplify this a little bit. We have 2 to the 5th here, 4 to the 5th here. We divide one by another one, and we get 2 to the 5th in denominator. Now, the nice thing is there's denominator the same for both of those fractions. So we can simply pull it out, and that's what we're going to do next. And then we want to open up these two parentheses using this formula. But before we do this, let's just look at this problem one more time. Remember what we did here. We found that there are two t's, two roots, that satisfy this equation. Then we said, let's just put one of them with plus sign. We put it here, and we got this formula. Now, obviously, we have to try and check the minus sign. Okay? So what's going to happen if I put a minus sign? Now, I'll leave it as an exercise, but I'm going to say one thing. If you put a minus sign there, all that's going to happen is these two terms going to change their order. So the first term is going to be with minus, and second term is going to be with plus. So what it tells us that it doesn't matter whether t is 3 plus square root of 5 over 2 or 3 minus square root of 5 over 2. In both cases, we get the same answer. Okay? So, and from that point on, really, this is the only expression for t to the 5th plus 1 over t to the 5th power. Okay? And as I said, we pull out 2 to the 5th out. Now I have these two parentheses. We open them up using this formula. There are 6 terms here, 6 terms here. So total 12 terms. So those green terms are from the first parenthesis. The blue terms are from the second parenthesis. But now interesting happened here. You find that some terms we see twice, some terms they actually we see with the opposite sign, so they're going to cancel. For example, 3 to the 5th green, 3 to the 5th blue. We add them up. Now, this term here, next one, here is with plus. Here, the same term with minus. They cancel out. The next term, this, and this, they add up. They're the same term, basically. We see it twice. The next term here with plus and with minus cancel out. This term and this term add up. They're the same. And the last one, 5 squared times square root of 5 with plus and with minus. So terms with plus and minus, they cancel out. The other terms, they basically we see twice. So we see these three terms twice, that's why there are two. But now, really, we can just simply use our arithmetic skills and figure out what 3 to the 5th is, what 3 to the 3rd is, 5 squared, 2 to the 5th, multiply whatever you need to multiply, add, divide. If you do all of it, you're going to get 123, and that's the final answer. Now, let me show a different way to get the same answer. Okay? For that answer, we will not need to find t. We will not be solving quadratic equation here, but we do need these two formulas. We need a plus b to the 3rd power and a plus b to the 5th power. Okay? So first, look at this term. It looks like t to the 5th plus 1 over t to the 5th. Okay? So there's power of 5. So how can I get the power of 5 out of this guy? I'll probably take this guy to the power of 5. Okay? And this is what I do. And then I use this formula to express this term. So in this case, a will be t and b will be 1 over t. Okay? Now I cancel what I can cancel. For example, there's t to the 4th divided by t, it's definitely t to the 3rd, t cubed divided by t squared, it's t, and so on. So we got all this, actually only odd powers. And now we can collect the terms actually with the same coefficient. If you look, the coefficient of 1 is t to the 5th plus 1 over t to the 5th. I know, but that's something I need to find. Now, the terms with 5 is t cubed plus 1 over t cubed. In terms with 10 is t plus 1 over t, and that I know, it's 3. Okay? So I know this term, it's 3 to the 5th power. Right? Then I get something, as I said, if combined the first and the last term, is something I'm looking for. Then I have this term t cubed plus 1 over t cubed, which I don't know what to do yet. And the last term I do know t plus 1 over t is 3. So I simplify it a little bit. But now, if we look at this, we see that in order for us to find this term, we need to find this term. And if I do find this, I'm done. All right, so let's write this equation. And now go and search for this term. As before with t to the 5th, we said, well, let's take t plus 1 over t to the 5th power. Now to find t cubed plus 1 over t cubed, let's take t plus 1 over t to the 3rd power. This is what I'm going to get. I can simplify this, right? Remember this t plus 1 over t is 3, so 3 cubed here. Now here I can also collect the terms together. This is t cubed plus 1 over t cubed. That's something I'm looking for, right? Because I need it in this formula. But this thing I know, it's 3. Right? So I got this expression, and after a little bit more manipulations, I get t cubed plus 1 over t cubed is 18. So, and now I'm actually done, really. So I need to put this 18 right here in the formula above, and that gives us the final answer. Well, not really final answer yet, so we put 18 instead of t cubed plus 1 over t cubed. Then take the terms, combine all the numbers, and we're going to get again t to the 5th plus 1 over t to the 5th, and that's 123.